Good morning, everyone, and welcome to today's webinar, our 8th of 2022. If you've missed any of our series, which has been running for over 2 years now, you can view them all on demand right here on our YouTube channel or on our Learning Hub at www.proctorgroup.com. You can also now register for our online members area, where you can access product information libraries, personalised CPD certification, and our free online U-value and condensation risk calculators. As always, you can also request product samples or arrange follow-up meetings to discuss the specifics of your project, or book one of our range of 5 REBA-assessed CPDs. These cover a wide range of topics, from passive house to pitch roof design, and can all be done either face-to-face with our team of experts across the UK or online. For today's webinar, we have a case study presented by our special guest, Frances Strachan-Friar of Studio East Architects. Since 2019, Frances and her husband have taken a hands-on approach to literally self-build their own home, from planning to construction on site. After the presentation, we'll have our regular Q&A session, where Frances will be joining our panel of experts to answer your questions. So, I'll now pass over to Frances to begin the webinar.
Good morning. My name's Frances Strachan-Friar and I'm a Perthshire-based architect working mainly in residential projects and one-off private houses. From that background, designing and building my own home presented a perfect opportunity for a learning exercise, exploring new construction methods, testing ideas and learning new skills by taking a fully hands-on approach on site. We started looking for a suitable site in 2019 with nothing specific in mind beyond a rural site with a few neighbouring buildings, with an easy reach of commuting distance of both of our jobs, and most importantly, the site and the location had to just feel right. The plot at Charleston Farm already had planning permission in place for a 5-bedroom house, but this was submitted in 2005. Subsequently, in 2015, the site was redesignated by SEPA as a flood risk area, being relatively close to the River Tay. In addition to changing the house type to the new design, our resubmitted application also had to provide flood risk assessment. This entailed demonstrating the proposed dwelling would sit as far as possible out with the affected area and the construction would be of a flood resistant type. Following our ground investigations, the structural engineer proposed a raft foundation which would help address the areas of poorer bearing pressure on the site. This type of foundation also lends itself really well to CLT, as the wall plate can be fixed directly to the slab and the frame erected relatively quickly without the need for blockwork subwalls. The recommendation from the flood risk assessment for the finished floor level was 600 mm above the adjacent 1 in 200 year flood risk level plus the 35% climate change levy. This meant our finished floor level was almost a metre above the existing ground level. Having the flood risk assessment done early meant that we could address this aspect and work the detailing into the project at an early stage. Fortunately, this part of the process went smoothly and the new planning approval was granted in May 2020. The design of the house was very site-specific and aimed to sit well with the neighbouring properties which were built in 2016 and 2019. Both of these homes are bespoke architect design properties and the overall aesthetic of the development is in keeping with the rural vernacular. We also wanted to connect to the previous use of the site, which was a dairy farm, and the simple pitched roof barn style of the house with metal-clad roofs is an ode to the old byres that once stood on the site. We were keen to use locally sourced materials wherever possible, and the larch cladding was supplied by the sawmill at Knapp, which is around 5 miles away from the site. This local agricultural context of the site provided a wealth of inspiration, and the simple forms of traditional farmsteadings, byres, sheds, barns and cottages never fail to create interesting spaces. The simple geometry of these structures also helps frame different views of and from the site, and the main spaces are focused on the garden side of the plan, which allows passive solar gain and captures the views across the fields. Managing this passive solar gain was an important consideration on this project, with the aim to cut the overall energy consumption of the house as far as possible. At the time of designing the house, I had started to become more interested in passive house design and the technical aspects of designing to the passive house standard. Having never worked on a certified passive house before, I decided to use the process of designing and building my own house to explore the possibilities of low energy design and working with passive house principles. While we ultimately decided not to go down the route of a fully certified passive house, we aimed to achieve as close as possible to the passive house standard as we could and to work continuously to identify areas where improvements may be required as we worked throughout the build. The core principle of passive house design is to minimise heat loss from the insulated envelope by combining high levels of thermal insulation with low levels of air leakage. The continuity of the insulation is also important, as is high performance glazing. The windows we chose are triple glazed and the principal rooms are kept south facing to maximise the solar gain into the property. To maximise the efficiency of the thermal envelope, I chose to use a cross-laminated timber or CLT structure. These structural panels, which are made up of multiple layers of machined timber, are fabricated off-site and then craned into position when they arrive, making for a very quick construction process. Being timber, the CLT panels are a more natural product than a foam-based structural insulated panel, and for me, they present a tactile and aesthetically pleasing internal surface which reduces the need for plasterboard dry lining. Cross-laminated timber, along with other mass timber construction systems, also have a variety of benefits in sustainable architecture, not least because the trees used to make the panels store carbon, which is then locked up in the timber construction for many years. The engineered nature of the panels also means that they can replace a lot of components that may otherwise require concrete or steel to be used. The lighter weight of the superstructure can reduce the amount of high environmental impact concrete required for foundations, as well as the site preparation associated with this. Cross-laminated panels are more commonly used in mainland Europe than in the UK, and in fact this project was the first time our Spanish CLT fabricator had worked in the UK. Onto the CLT base, we applied the Wraptite Airtight and vapor permeable membrane directly onto the surface of the panels. By wrapping the building entirely in this membrane, we were able to quickly and easily achieve a continuous airtight seal around the insulated envelope, as very few surface penetrations were required in the airtight layer. This simplicity helped us achieve a final air pressure test result of 0.681 metres cubed per metre squared per hour at 50 pascals. Considering we hadn't installed an air barrier before, we were really happy with that result. Like most of the manufacturers whose products we installed, Proctors were great in providing help and advice throughout the process. We had a toolbox talk from the team prior to starting, and the process was pretty smooth and painless. Over the barrier membrane, we fitted wood fibre insulation, again keeping to natural materials where we could. We used 260mm on the walls and 280mm on the roof to achieve a U value of 0.11 in the walls and 0.10 to 0.12 across the different roof areas. This was fitted using thermally broken fixings because the CLT panels form the structural support. The insulation layer is almost completely unbroken around the building, which reduces any thermal bridging. This permeable insulation over the permeable Wraptite air barrier over a relatively vapour-resistant inner panel gives the building good hygrothermal characteristics, with the outer layers allowing moisture to escape evenly and ensuring a healthy indoor environment, while the inner layer slows down the ingress of moisture into the structure and limited the scope for condensation risks to arrive. CLT structures with high levels of external insulation like this are very good in this respect, as the more vapour-resistant CLT panels are kept warm by the insulation layer with the temperature remaining well above the dew point. Indoor air quality is further improved by the use of a mechanical ventilation system with heat recovery, which uses heat from the exhaust airflow to pre-warm incoming fresh air. This system ensures that sufficient air changes are achieved throughout the living spaces without dramatically affecting the energy performance. Our focus on a high-performance, fabric-first approach to energy performance meant we achieved a 106A SAP rating with a dwelling emission rate of minus 3.99 against a target emission rate of 20.79. This negative emission rate is a product of the high efficiency of the building envelope combined with the extensive use of mass timber and wood fibre throughout the building. We were extremely happy in being able to achieve such a good result, having undertaken so much of the installation ourselves. especially having been learning skills as we needed to progress the build. We decided from the outset of the project that we wanted the build to be a learning process, not just in terms of the design approach taken and the technology specified, but also to take the opportunity to be far more hands-on with the construction itself than is usually possible for an architect. While there are inevitably some tasks, such as electrical work, where a certified professional is required, and others, such as foundations and the erection of the CLT panels, which necessitate the use of heavy machinery, our aim was to attempt as far as possible to truly self-build the house. This gave us a bit more control and flexibility over costs, in that we could prioritise processes that required a faster turnaround and take on less time-critical processes ourselves. Inevitably, tasks we undertook ourselves were a lot slower, not least as all the work had to be fitted into evenings and weekends around full-time working. Learning all the necessary skills also took time, and in hindsight, we didn't always approach tasks in the correct way, and certainly not in the most efficient way. This is probably one of the main time saving associated with experienced contractors. The knowledge of the quickest and most efficient way to proceed with a job isn't something that can be gained quickly, however hard you try. Fortunately though, because we were doing the work for ourselves, that allowed plenty of time to be taken to ensure we got the right result, even if the route there wasn't optimal. Manufacturers and suppliers generally provided good resources to explain the process, and YouTube is a fantastic resource for informal training. 99% of the issues we came across, we were able to find someone who had not just had the same issue, but who had also made a video of how to address it. This learning process is fed back into my approach to design in a few ways. My approach has always been to aim for a site-specific design and keep things as straightforward as possible, as simplicity always works best. Being able to apply the detailed design to practical situations and adjust and amend them to reflect the skills we gained along the way was a great opportunity to gain a valuable insight into the build process. This appreciation of the process is something that will prove useful in future discussion with contractors. I think having good communication with contractors is key to ensuring things can be built in the best possible way. The way an architect has drawn something may not always be the best way to build it, so there has to be a bit of give and take. As long as design decisions are openly discussed on site and both parties are willing to learn from each other, the end result will be something to be proud of. So while it was good to have the freedom to take decisions and understand directly the implication of those decisions, the lack of feedback from a third party occasionally impacted on the cost, time and practicalities of the build. As is the case with more or less every self-build project, cost was a really important concern here. While some cost overruns are inevitable as a project progresses, in this case the wider economic situation since 2020 has increased costs across the whole build by around 20 to 30%, which has been really difficult to accommodate. For the most part, we were able to do this by value engineering some items and taking on more of the work ourselves, but doing this also increased the likelihood of running into additional costs due to the extended timescale. To help fund the build, we opted for a self-build mortgage. Due to the nature of the CLT frame and off-site construction, it meant our choice of lenders was quite limited. We used a self-build mortgage broker to set up our mortgage, and once the lender was agreed, the process was relatively straightforward. The stage release milestones were agreed at the start with the lender, and we have 2 inspections once we reach each stage by separate surveyors, along with an inspection by a professional consultant, who in this case is another architect. Under the ARB-RABA guidance, I cannot self-certify my own project, as this would be a conflict of interest. With a self-build mortgage, the interest rates are slightly higher, so once we have completed the build, we'll be able to move to a standard mortgage. So this serves as good motivation to keep things moving forward. Tools in particular were also an area where we didn't expect costs to be as high as they were, or didn't fully appreciate the items that would be required. Because we only had a very basic selection of tools at the start of the build, we had to spend quite a lot to make sure we had the right tools to complete a variety of tasks on site correctly. Wherever possible, we did try and buy second-hand items, and we do plan to sell these on once we finish so somebody else can have the use of them. In other cases, undertaking work ourselves resulted in us undertaking tasks that were simply awkward and where the satisfaction of completing the job did not outweigh the problems along the way. A particularly good example of this was installing the large corrugated metal roof sheeting for the roof and the walls. While these were an important part of both the weather protection and the overall aesthetic of the house, the relatively exposed nature of the site made manually handling these panels in windy conditions particularly tricky. Cutting and shaping the corrugated panels correctly and ensuring all the trims, flashings and other accessories required were fitted and aligned properly was also an area where our learning curve as first-time installers was a little steeper than we would have liked at times. On the other hand, plasterboarding, plumbing and scaffolding were some of the more fun tasks we undertook, where the learning and satisfaction outweighed the hard work. Overall, the project has been a fantastic experience, and it's really allowed me to gain in-depth, practical site experience that's invaluable to my professional practice. I think the feeling of accomplishment and pride in our work will be something that we can look back on, and the knowledge that we physically built our own home will bring a great sense of achievement and satisfaction. We're continuing to work on the house, and we hope to be able to move in before the end of the year. Thank you very much.
Good morning, everyone. Welcome to our live Q&A session. My name is Carol Mikulak, and I am here to put any questions that you may have to our panel of experts. So please drop anything that you want to ask into the YouTube chat feed here, or alternatively, you can send us a direct message to our Twitter page at Proctor Group, or you can email them over to webinar@proctorgroup.com. If there is a project that you're working on yourself, or you would like to discuss something in a little bit more detail with one of the team, please just get in touch, leave some contact details, and we will certainly get back to you as quick as we can. Now, I hope everyone enjoyed today's presentation, and if you have registered today, you will, as always, get an follow-up email from us, which will include a link in there to watch back the full presentation and this Q&A session in your own time. I know a lot of people really do appreciate being able to do that, because there is an awful lot of information to take in at the first watch. So you can also watch back any of our previous webinars from the past 2.5 years, and these can be accessed from our YouTube channel or from the online members area of our website. Please, if you can, subscribe to our YouTube channel, give us a thumbs up, and do leave some feedback as well. All feedback is taken on board, and it helps to shape the content for future webinars. Now, a date for your diary for our next webinar, which is taking place 2 weeks' time, Friday the 26th of August, usual time of 10 AM, where we will be going through understanding membranes in ventilated rain screen facades. Now, this is a technical guidance document that's been released by the Metal Cladding and Roofing Manufacturers Association. This document details the fundamentals of membrane performance in facade systems and how this relates to the guidance given in BS 5250-2021. We will also be joined by MCRMA Director Carlton Jones. Another one not to miss. So mark this in your calendar and register to join us back here in 2 weeks' time. Okay, so let's now move on to our Q&A session, and let me introduce you to our panel for today. With me today, we've got Sue Memure, who is one of our technical advisors. Good morning, Sue.
Hi there.
Next up, we've got Callum Anderson, another one of our technical advisors. Good morning, Callum.
Good morning, Carol. Good morning, everyone.
Next up, we've got a new face for you today. We've got Bruce Manning, who is our National House Builder Manager. Good morning, Bruce. Oh, Bruce, are you with us? I think he's frozen a little bit. Don't worry, we'll come back to him. And finally, our very special guest for today, who you heard in the presentation earlier, Frances Strachan-Friar. Good morning, Frances. Thank you so much for joining us today.
Good morning. No problem.
Fabulous. Great. Now, I am really pleased to see we've got some questions coming in on YouTube already, so let's just get on with them. So if I can come to you with this first one on YouTube from Paula Sinclair. Paula says, I note this project was not fully passive house certified. Do you have any products which are certified by PHI?
We do indeed. We obviously have the Wraptite, which, as everybody saw, was used on Frances' project. This is a Passive House certified component. We also have our ProCheck Adapt, which is a variable performing vapor controller. That also went through the process at Passive House Institute. Both of these membranes have been independently assessed, and they both achieve a category A in terms of airtightness.
Perfect, thank you, Sue. I think Bruce is having a little bit of an audio, so we'll come back to him in a little minute once he's okay. Frances, can I come to you with this next one on YouTube? We'll just stick with these questions for now. From Joseph Masterton, what are the main tips for starting a self-build project?
So I would say that the key thing at the start is to define a clear budget and make it as detailed as possible. So costing out absolutely everything that you can at the outset. It's also really helpful to put together a project program and think about what work you would like to do yourself, if any, and what work the different contractors are going to undertake. Be prepared to make changes as you go along and adapt, because things on site may not match up with what your original brief was or your original idea was. And flexibility is really key when you're doing a self-build project. I would also say appointing a professional consultant, which may be an architect, to help navigate the process is a really helpful first step. And they will be aware of how to make, first steps on your process in interpreting your brief and helping guide you through the entire project. And make sure you have a detailed discussion with your consultant at the outset in terms of your budget, your ideas and your brief, so they have a clear idea of your goal.
Perfect, thank you, Frances. Callum, can we come to you for this next one, sticking with YouTube, from Charlie Smith. Charlie Smith asks, how important is airtightness?
It's incredibly it's incredibly important to be airtight. So airtightness is a measure of the building's efficiency. So it's the measure of how much air is lost through gaps or cracks in the building facade. It's looking at controlling any of the uncontrolled air leakage. And making buildings more energy efficient, as that would do, is very important, especially as energy prices rise. So as an example of how important airtightness is, if you had a building with a air change rate of about 7 meters cubed per meter squared per hour, which was the target for airtightness just before it changed, and a U value of 0.13, that might have the same dwelling emission rate as something that had an air change rate of 1 meter cubed per meter squared per hour and a U value of 0.28 or so, which would be effectively more than double the thickness of insulation you would need for that.
Perfect, thank you, Callum. Lots to take in there, lots of figures. Callum, if I could just stick with you, if that's okay. I think Bruce is having a little bit of issues with his audio. I think don't worry people, we're looking at this from behind the scenes. Callum, if I can stick with YouTube, Simon Matthews has asked, operational performance sounds great. Embodied carbon also looks encouraging. Do you have any calculations for embodied carbon and or assessment versus REBA 2030 standards?
No, we don't really have many SAP figures for that sort of thing at all. We may have some historical data, so if you can email me, then we might be able to look that out for you. But I don't think that we have any figures for that sort of thing as compared to the REBA standards.
Okay, thank you very much. Let me just jump onto a couple of emails that have come here. Sue, if I could give you this one that's come in from Jamie. Jamie says, this project achieved an airtightness level of below 0.7. Will this be applicable to all Wraptite projects?
Okay, so this is probably the it depends answer. Obviously, I mean, like the overall achieved airtightness level is not solely reliant on the membrane alone. Although Wraptite's excellent airtightness properties does make it easier, but the entire construction and the level of workmanship all contribute towards the actual overall performance. You can have the most airtight membrane in the world, but if it's not installed correctly, then that will show in the results that you achieve. We do offer our toolbox talk, however, to sites which, like we're perhaps installing it for the first time, for example. And this goes through typical installation points and areas to look at, which might need a little bit more care, such as the awkward detailing, junctions, etc. So feel free to get in touch if this would be useful, and we can get that arranged.
Absolutely. Toolbox Talk is actually proving to be really popular. So like Sue says, get in touch and our guys would be more than happy to come out and do that to you all. Frances, can I come to you with this next email again? This time Carson asks, what are the benefits of the products you choose to specify for the project?
So we tried wherever possible to specify products that were sourced locally, such as Wraptite, obviously based up in Blairgowrie, so that the manufacturer support was easy to access. And we, as Sue mentioned, we actually had one of your toolbox talks for installing the Wraptite because we'd never installed it before. That was really helpful and just sort of set us off on the right foot before we applied the Wraptite membrane. And also, if we needed any additional materials, we did at one point run out of a little bit of Wraptite. So it was easy to just pop up to Blairgowrie and get some more from you. So I would definitely say sourcing materials locally is a really good idea. We also sourced our timber cladding and things from a local sawmill and other products, as locally as possible.
Fabulous. Can I stay with you, Frances? A couple of questions from Steve on YouTube relating to this. Did you install Wraptite on site or at the CLT factory? And if on site, was it you who stuck it on or the contractors? And what training did they need? That kind of refers into the toolbox talk.
Yeah, so it was applied on site, and we don't have a main contractor because we're doing most of the work ourselves. So we actually did apply it ourselves. We had the toolbox talk from Proctor before we started, and then we just cracked on. So yeah, it was us that did it. And once we'd had a go at it, it became a lot easier. They also do preformed corners. So Carol mentioned the kind of tricky detailing around window corners and jambs. So they do preformed corners for those areas, which were really helpful and just allows you to get that complete airtight seal in all those little tricky junctions.
Perfect. Thank you so much. Bruce, I think we're back online with sound now. Oh, take yourself off mute. You're still on mute. We've a few teething problems here today. You're still on mute. We'll give him a little minute. You'll need to take yourself off mute. Sorry, Bruce. I know we've had a little bit of technical issues there, just everybody getting set up. Is he there? Is he with us? No, okay. We'll come back to you, not to worry. Callum, can I come to you for this next one? I have got a Twitter message this time from Sarah. What other options for membranes are there in a self-build project?
We actually have quite a wide range of membranes that you could use for self-build. There's obviously our Wraptite, which Frances has demonstrated on her house. Just this year we introduced our Wraptite UV, which is a very similar membrane but designed for behind open jointed cladding as well, so it's a self-adhered thing. And so both of those offer really excellent airtightness. Then there's also things like our facade shield UV, which is similar to the Wraptite UV in that it can be used behind open jointed cladding and creates a nice shadow gap. But it's not self-adhered, it's a mechanically fixed membrane. And then along similar lines to that, we have things like our reflector shield, which is our market-leading reflective grade of membrane, which increases the thermal performance. And we also have a number of vapor control layers, which are useful in self-builds as well.
Perfect, thank you, Callum. Right, let me see if we can try again. Bruce, are you with us today? Yay!
Yeah, Carol, I am. Yeah, sorry. Unfortunately, I lost and I couldn't actually hear anything, and then I lost the video, so I couldn't unmute myself. So,
don't worry. You know what?
Good morning, everyone. I've made it at last.
I kept this question. I'll go back to this question that came in on YouTube. It was one that was probably most pertinent to you here, Bruce. Greg Robertson says, are builders looking at Wraptite as a solution to help them achieve airtightness?
Oh yes, most certainly. Mainstream builders building blocks of apartments are using Wraptite with facade cladding to help reduce energy costs, reduce CO2 emissions and meet building regs. And this also improves the health and comfort of the homeowners. It's also being used by a number of MMC home manufacturers, these modern methods of construction, off-site building sort of slabs that are sent to site. This sees the Wraptite applied to the construction modules, which are then assembled on site with their airtightness already in line. And also it means that they arrive on site very well because obviously the membrane being self-adhesive sticks to the modules. This speeds up construction process on site significantly for those builders using it. And smaller builders, regional builders, are using Wraptite to differentiate the houses they sell from others by offering energy efficient homes by reducing heat loss through air leakage. So Wraptite helps the thermal insulation achieved in its as designed target, it actually gets very, very close to the as built performance by creating better airtightness.
Perfect, thank you so much. Frances, I'll jump back to you with this one. This is a question I actually asked Callum earlier on. Simon Matthews has come back in. This question about the embodied carbon, he was actually asking more about Charleston Farm project. The original question was, operational performance sounded great, embodied carbon also looked encouraging. Do you have any calculations for embodied carbon or assessment for the REBA 2030 standards? Callum's maybe already covered it, but sorry, my mistake, Simon, asking that to Callum when you wanted it directly to Frances.
That's okay. So we do have an embodied carbon, or we will have, sorry, I should say, an embodied carbon report for the CLT frame from the CLT manufacturer. So that was sourced from via a company in Inverurie. We used to do the CLT frame, and they are able to provide a kind of embodied carbon report. I haven't actually got that yet, but I'm hoping to get that pretty soon. And as I say, we don't have a specific overall embodied carbon calculation for the whole building, but that is something that, you know, in future projects I would hope to be able to do for the 2030 standard.
Yeah, perfect. Stick with you again, Frances. Colin Christie's asked on YouTube, was the 20 to 30% increase to the budget cost since 2020, was it due to inflation effect of COVID and the fallout of Brexit? Or was it basically an underestimate of the time, material and labour resources required?
It was probably a bit of both. So material costs, when we kind of started to cost the project, it was mid-2019, and we purchased the site obviously in October 2019. So that's when we kind of did our initial costing. Then obviously COVID kind of came in, and when we were actually starting to purchase materials, which was last year and maybe towards the end of 2020, costs had gone up because there was very significant cost increases for materials at that point. We tried to mitigate that by buying in bulk and storing materials on site where we could, but there was an element that some materials we just weren't able to buy at the outset, and we had to wait until we had a building, example plasterboard, that sort of thing. So those items were more expensive than our initial budget had estimated. Things also taking longer because we're doing a lot of the work, or we're doing all the work ourselves. So things like scaffolding costs, having scaffolding on site longer than we had anticipated originally, increased the cost overall. So I think it was a combination of both and all these kind of factors that have contributed to that increase.
Excellent, thank you so much. Bruce, let me come back to you with this one. I have an email here from Alex. Alex says, how does Wraptite help with the healthy internal environment of the home? Oh, you're still on mute again.
Wraptite is vapor permeable, and it allows the moisture created during the build to dry out quickly. And in occupation will help water vapor from cooking, washing, showering, etc. To pass through the vapor permeable construction to the outside. This reduces the opportunity of mold, mildew and condensation build up internally, obviously, which is detrimental to the health of the occupants. And obviously using Wraptite is beneficial because of the these buildings are now being sealed up a lot more.
Excellent, thank you so much. Right, Callum, can I come to you for this next one? This has come in from, on YouTube, from Daniello, sorry. And he says, we are installing Wraptite on our residential project as a VCL and an airtightness membrane. Wraptite will act as the EPDM around the openings. Our most concern is to have a robust airtightness detail.
Okay, so to start off, it's not a vapor control layer. A vapor control layer is vapor impermeable, and I see that someone further down the chat has commented that as well. Wraptite is very vapor permeable, so it is a breather membrane. If you're installing it externally on your building, it will give you a very robust airtight line. And as you say, you can install it around window details as well. You will likely need, you won't be able to replace all of your EPDM with Wraptite. You will likely need some, just to provide a seal to the windows mostly. But it certainly reduces the amount of EPDM that you would need.
Yeah, perfect. Thank you. I think we've got another question in there from Ensign Design that kind of covers the same sort of thing there. Can you discuss the differences in where to position the Wraptite within the wall construction? As I note, this was placed onto the CLT, not outside of the installation. Do you want to make further comment on that one, Callum?
Yes, I can do. So it was placed onto the CLT because that gave the best substrate for a solid and robust airtight line. The Wraptite was able to adhere fully to the cross-laminated timber and make the entire building envelope airtight even before the installation went on. You could use a further membrane outside of the installation, something like our facade shield, just to protect the membrane, especially if it was protect the installation, especially if it was behind open jointed cladding, something like that.
Excellent. Thanks, Callum. Okay, so can I come to you with this next one? We've got an email that's come in from Raj. Do you have any temperature constraints when using the Wraptite or the Wraptite tape? What is the lowest temperature you can apply the product at?
Okay, so Wraptite can withstand quite a fair range of temperatures actually. Installation wise, we would say you can install it between -10 degrees and +60 degrees. Its actual in-service temperature range would be not that I would expect to get -40 here, but up to +100 as well. Probably the more important things to consider is just, as with any adhesive membrane, is making sure the substrate is clean and dry, dust-free, etc. for getting that initial adherence.
Perfect. Excellent. Thank you very much. Frances, can I come back to you? I've got lots of them firing in. Lots of people want to ask you lots about your project. Steve asks, did the flood risk affect your choice of vapor membranes or external cladding? Oh, sorry, he's added a supplementary. I'm not reading far enough down. How did the wood fibre on the outside handle the weather before it was clad? Maybe you can cover both of them for Steve.
So the choice of cladding itself, we have obviously the corrugated metal cladding and timber cladding. So those were decided with the flood risk in mind, but they shouldn't really be affected by the flood risk because of the raised floor level. So as I said in the presentation, our floor level is almost a metre in some points above the external ground level. So the actual cladding itself should be pretty safe from any potential water damage. The external wood fibre insulation, obviously that's a kind of a semi-rigid board, but if it gets wet, it does kind of crumble. So we had to be very quick at applying that and then applying the breather membrane to keep that weather tight. We do have the bottom kind of base detail on the raft slab. The first 300 mil is actually XPS insulation. So the wood fibre is raised up a further 300 mil over the slab level, just to prevent any water damage or any potential water ingress getting to the wood fibre.
Excellent, thank you so much. Bruce, can I come back to you for this next one? We have a message on LinkedIn from Drew. He says, where can we source Wraptite for our self-build project?
Our usual route is through the builder's merchant, and we deal with most of the major merchants for Wraptite, along with all of our other products. And they obviously stock the range. We also work with a lot of smaller and local merchants. So if there's someone out there that someone's got a self-build project and they want to use them, they should contact our sales office, and it may be they've already got an existing account with us as well.
Excellent, thank you so much. Callum, can I come to you for this next one? Another email here from Robert. Robert says, what considerations need to be made regarding fire?
Okay, so fire is a bit less of a concern in low-rise self-build projects than it is in high-rise projects, for example, over 18 meters. So for most walls in a self-build project, you don't need to ensure that things are a certain fire rating, for example. The main difference there is at boundaries. So if you're less than, I think it's a meter from a boundary, pardon me, less than about a meter from a boundary, you do need to ensure that the walls are, that membranes in the walls are class BS3D0, which Wraptite can meet on certain substrates, or you have things like our fire shield, which would also be a good consideration there, as that's it actively suppresses fire.
Perfect, thank you so much. So can I come to you for this next one? Another message on Twitter, this time from Orla. She asks, we are embarking on a self-build ourselves. What services can you offer which may help us?
Oh, right. Okay. So we have a wide range of services, as you know, that we can offer to people. From a technical point of view, we can do U-value calculations, condensation risk analysis, WIFI calculations as well. We're happy to view drawings and make comments, and also obviously put forward suitable products that would, that would fit in with your actual build. We are happy to speak to your architect, your contractor, your specifier, etc., on your behalf about our products, about their performance, and also how they're installed. As we mentioned earlier, we can come onto site to do talks, but also on our website in our members area, there's our online U-value calculator that you can actually log on, sign up, log on, and you can run scenarios through yourself if you just want to see what sort of performance you're going to achieve, based on your construction.
Perfect, thanks. Yeah, like Sue says, our online members area, there's a huge amount of content in there, so do take the time, go in, register, have a look around. There's a minefield of information that you'll certainly be useful for. But as always, pick up the phone, give us a call, drop us an email, and we always like to know what you're getting involved in. Frances, let me come back to you with this next one. An email again from Graham. How do you keep costs under control during the build?
So I suppose this also depends on your kind of chosen route for construction. So if you've got a main contractor on board and they're doing your construction, they will generally be able to provide you with a fixed cost for the project at the outset. And any changes to this would really only result if there's a drastic rise in material costs, before or during the project for certain items. And this would be reflected in the costs that they pass on to you. Or if you make any changes to the design on site, that can also result in cost changes to the overall tender. If you're going down the self-build route, which is what we did, as I said, costing as much as possible up front, albeit things do change throughout the length of your build, which will generally be longer than a main contractor build. So the best idea and the way we've found to do it is just to try and keep on top of those costs, keep checking back with manufacturers and suppliers, builders, merchants, to see what their costs are. They'll often notify you of any cost increases that are coming, so you're able to perhaps purchase things before that to mitigate that rise. And also looking at bulk buying as much as you can up front to try and mitigate any future cost rises.
Excellent. Frances, can I stay with you? Colin's asked another question on YouTube. Noting that the 1 in 200 year flood protection required the building to be raised 1 metre, did this affect the levels of the access road into the site?
So the access to our site is actually, it's a courtyard that was formed when the development was first started back in 2005. So that was already in place, and the access road is set at those levels before the designation by SEPA as a flood risk area. So the access road is obviously lower than our building, and then our floor level sits above that. So our driveway will actually be graded up to the kind of finished ground level on our project, and then we'll have our ramped and stepped access to our building. So the various different houses that are built in the kind of small development, as you go sort of from the oldest one to the newest one, they get slightly higher because that designation obviously came in 2015, and the ones that were built before are lower. So it's a bit of a mixture, but the access road itself was already there, so it hasn't changed.
Perfect, thank you so much. Sue, can I come back to you with this one? I've got an email here from Edward. He says, I'm doing a new build timber frame. What are the pros and cons of the various insulation types?
All right, okay, so typically in a timber frame construction, you would generally tend to use something like polyurethane, polyisosanurate insulation. And this is due to the thermal efficiency related to the thickness of those materials. We could provide our space therm, which, as you know, is extremely highly thermally efficient, and that would give a fantastic performance, but this would be the high-end option in terms of costs for a timber frame. There are other options obviously available. If you are looking for a sustainable option, for example, you have the likes of hemp insulation. This has relatively good thermal performance with a K value of round about 0.035. It's breathable, locally produced, and I believe it's actually a carbon negative crop as well, so all good.
All good, fabulous. Now, actually, we only have another couple of emails here left, so if anybody else still would like to ask something, please drop it into the chat now, or you can still get in touch, leave your details, and we would certainly come back to you. Callum, can I come to you? This is an email that's here from Roger. From the picture, the farm used Wraptite on the roof. I didn't realise that was an option. Is there anything special that needs to be done to use it on a roof?
Okay, so Wraptite certainly can be used on a roof, as Frances's house demonstrates really nicely. It's actually also it also has a it has a separate BBA certificate just for its application in non-ventilated core and roof constructions. It is obviously fully self-adhered, so you would want it fully supported. So you would need to either use sartan boards or CLT, as Frances has done, or fully fill the rafters with a rigid insulation that it could adhere to. But doing that, and as long as the roof is a warm roof, so the insulation follows the line of the rafters, either under the Wraptite or, as Frances has done, over it, you certainly can use it as an excellent roofing underlay. In terms of other options for the roof, we do also have Roof Shield, which is a much better option if you're doing a cold roof, because it doesn't need the ventilation under it there.
Fabulous. Thank you so much, Callum. So much information to take in with all this today, but as I said at the start, if you've registered, you will get the replay link to watch this all back, so you can pause it and replay it and listen to lots and lots of information. Now, I think actually this might be my last question, unless any sneak in quickly just before we finish here. Bruce, if I could give this last one to you. We have an email here from Terry. Why is Wraptite fitted to the external face of the wall? We've covered bits of that, but I think you can probably finalise that one for us.
Yeah, I think Callum has answered some of that earlier, but Wraptite's not a vapor control layer. A vapor control layer is an airtight membrane which resists the passage of water vapor. These are generally positioned inside the insulation to prevent the passage of water vapor into the construction. A vapor permeable membrane, also I suppose some people call it a breather membrane, such as Wraptite, is used as a secondary layer of protection against the external water ingress, and some, such as Wraptite, also provide airtightness. By being placed externally, Wraptite creates a robust airtight line that has less chance of air leakage due to fewer penetrations through it. Typically, such penetrations occur on the internal fitted vapor barriers, where surfaces and other interfaces, things like your TV boxes, your plumbing, cause damage to the airtight line.
Excellent. Thank you very much. I just realised, Freddie, you hadn't made a comment on what you'd said about the Wraptite. It's not a VCL. Yes, you're correct. And hopefully we've covered all that for you there with those last few questions. Now, I think actually that's me covered everything for today. If there is anything at all that you would still like to ask, I know probably people have got lots of more questions they'd like to ask Frances. Please get in touch. If you would benefit from a one-to-one with any of our team, just let us know what you're working on. As I say, we always like to have a chat and see what people are working on out there and get involved if we can. Please do subscribe to our YouTube channel, give us the thumbs up, as well as leave some feedback. And do register now for our next webinar that's taking place 2 weeks today, Friday, the 26th of August, 10 AM, where we will be addressing the MCRMA guidance document GD40, covering understanding membranes in ventilated rain-screen facades. And we will also have very special guest, MCRMA Director Carlton Jones. Well, all that's left for me to say is thank you for taking your time out of your busy schedule to join us once more this morning. Thanks to our panel and to everyone behind the scenes. Few glitches there today, but as we always say, live TV, you get what you get. Very extra special thanks to Frances for her fantastic presentation and for sharing her project with us. Absolutely fantastic. Really, really can't thank you enough for that. So goodbye from all of us. I hope the weather stays. It is sunny up in Scotland, doesn't happen very often. So wherever you are in the country, enjoy the rest of your day and have a wonderful weekend. Take care, everyone. Bye.
Bye.